Hi, everyone. We'll get started here in a couple minutes, right at the top of the hour. Thank you.
Hello, everyone. It's 5 p.m. Norway time and 11 a.m. Eastern time. We'll give it one more minute for people to arrive, and then we'll get started with the webinar. Okay, everyone, welcome to the webinar on teaching LLMs to see, hear, and act, a technical framework for situational awareness. My name is Michael Hildebrandt from the Institute for Energy Technology in Norway. Welcome, everyone, from HFES members, HFES Nordic members, Augmented Cognition Technical Group members, and everyone else. By way of introduction, I would like everyone to go in the chat and just write your affiliation and your interests. So for me, that will be Institute for Energy Technology, eye tracking, and language models. So if everyone can just click on the chat and introduce themselves real quick. Okay, don't be shy. I can't see anyone else. There we go. Okay, I'm sure we have more people. There we go. Very good. German Aerospace Center. Hallo. Guten Abend. Good, good, good. Sweden, welcome. Okay, I think while people are typing, if you have just recently joined, please introduce yourselves in the chat. I will get started with the webinar. So this webinar I see mainly as a tutorial. I want to talk about the experience we had with connecting language models and simulators and language models and sensor data. I'm going to show a few videos. I'm going to show you some demos. I'm going to show you some architectures. If you came here for strong discussions about situation awareness, it's probably not the right webinar for that. The situation awareness conversation is more of a clickbait. I think we can talk about it, but it's not. I think it's not the talk where I want to argue if language models can have situation awareness on a philosophical level. This is going to be quite a pragmatic seminar where I want to just share some ideas that you could pick up. Okay, let's move on. I just want to remind everyone that this is a joint webinar for the Augmented Cognition Technical Group and the HFES Nordic chapter. If you're an HFES member, please remember to join the ACTG next year or today. I will be next year's chair for the Augmented Cognition Technical Group, and we have a lot of interesting activities planned, including tutorials on eye tracking, physiological measurement. If you're in the Nordic countries, you can join HFES Nordic. It's free. Just send an email to hfesnordic@gmail.com or contact us on our LinkedIn page. So that out of the way, let's do some self-promotion or self-explanation. I work at the Institute for Energy Technology in Halden, Norway. I lead the biometrics lab, and now it is being extended into the human AI lab. So the lab focuses on multi-user simulations. So we're interested in driver-pedestrian interactions or pilot air traffic controller interactions. Our biometrics focus mainly on eye tracking and motion capture, and I'll show you a video about that aspect. We have experimented with other sensors, but eye tracking is the most pragmatically useful for us. I will also show some material on the air traffic control simulation side, because that is very, very interesting for the integration into a language model setting. I just want to mention two papers that we have produced on language models. The one on the right is more about automatically generated safety analysis, and the one on the left is pretty much what I'm talking about today, situation awareness and sensors and simulator data. It's under review, so it's hopefully will come out next March. The Biometrics Lab also has a number of software, open source software packages that we have developed since 2016. I will show some videos about them. Synopticon is our data fusion platform. Now we are re-implementing it from scratch as an AI native or AI compatible data fusion platform. So that's kind of also a core of what I'm going to talk about. What would a system look like that where a language model or an AI can really access a lot of the data that we have in a simulator environment. Okay, those are the preliminaries. Let's go and look at some real use cases. So, as I said in the abstract, I'm interested in flight crew behavior. And of course, in the biometrics world, we've long used all sorts of sensors to get a better insight into the workload or the attention focus of flight crew. So I'm going to first show you a video of how we did that before the LLMs, and then I'm going to show the architecture and some examples of what an LLM could bring to that conversation. So let's jump to this video of Synopticon. So those of you who have known me for a bit, they are probably sick of this video because I've shown it since 2016. It's going to be soon retired, hopefully, but I will give it one more play. So this is a video from a demo or a test we did at the flight school at University of Lund. It's a 737 full scope simulator. And as you see in a moment, it's not a VR simulator, it's a real flight simulator. But of course, if you want to really get a bit more of an insight into what pilots do on the flight deck, Normally, as an instructor, you sit behind the pilots and you can listen to them. You have to pay attention to the scenario, but you can't really track a lot of other data. So you can't track very easily the gaze patterns of the pilots. You don't get a summary of what they're doing. You can't really track their hand movements really well. You don't get statistics, real-time statistics. So back then, 2016, we developed Synopticon as a data fusion platform. So at the top, you now see a camera view of the simulator. And this is kind of the view that an instructor would have. In a second, you'll also see what eye tracking would add to that, which is this view. So if you imagine you're an instructor, it will be very hard to follow those dots and make any sense of it because things happen so quickly and you also have to follow the scenario. So we built this tool, which is quite a kind of a comprehensive, fun tool. Just a few comments because I have the time. So Synopticon works, as you can see at the video, in the little video in the center, by combining motion capture and eye tracking glasses. So we know exactly where in space the eye tracking glasses are, and we combine that with a gaze vector from the eye tracking glasses to get an absolute positioning of the gaze point. And we map that onto a 3D model of the environment. The 3D model is also created in Synopticon. So we have process to measure different, the layout of this 737 cockpit. And so the model you can see there was created with the optical system, and it's accurate to about 1 millimeter. And it took us about 45 minutes to an hour to make it. So we're quite proud of that achievement back in the day. And then Synopticon can also support, it's not available on this simulator, but if you have textures like a primary flight display from the simulator, you could overlay it. Here we just overlaid some textures that we predefined. One of the limitations or features in some ways of these professional simulators is that they are often not very good at giving you data access. So we couldn't really track when the pilots would change the autopilot or move the throttle. So we also implemented hand tracking and a collision system so that we would know when they point or push a button. So the buttons would be little areas of interest that would be sensitive to intersection with a hand. So we managed to recreate some of this data. It's a nice system because it also allows you to instantly replay the recording or to get these statistics. You can jump from one pilot to the other. You can dynamically set the heat map. So if you have an engine fire, you say, I want to see how the gaze distribution is from the engine fire for the next 3 minutes. So it's a very, very neat system. So that was back in 2016. Those of you who work with eye tracking probably also know that it doesn't really get used that much in real world applications. So there are some efforts now to use eye tracking in daily training at airlines. Hopefully they will be successful. I think it's exciting what's happening, but a lot of the time it stops at a feasibility study, the same as it did for us. And of course, it's pretty clear why that happens, because even though this puts a lot of data together, it still is a lot of effort for the instructor to make sense of it, to get an actionable results. And then the question is why, of course. So we will come to that. Now we are in the era of AI and language models, and they are not the silver bullet, of course. But I want to first talk about what makes this era a bit different from then. So at the moment, we are in the process of writing Synopticon from scratch to make it native, AI native, or to make it really communicate well with language models as a way to analyze the data. And that is what I'm going to talk about next. But before I get to that, I'm going to go on a little, not necessarily a rant, but I want to make a point. And that is the point about human factors and AI. I think it's really exciting that in human factors, we are now engaging with a lot of AI topics. And of course, as human factors, we are not fanboys of technology most of the time, but we usually have a sober, critical view of these. But I think we can do a little bit better in our discussion and in our treatment and investigation of AI tools. Because sometimes some of the conversations I hear focus on very, I wouldn't say superficial topics like hallucination or sycophancy, but I think we need to engage more. We need to really use these tools a lot. We need to really understand, engage with language models. We need to dig deep in when they hallucinate, why they hallucinate. I think it's not really good enough to say language models always hallucinate. That's why we can't use them for X, Y, Z. That might be correct on a philosophical or a technical level. But on a pragmatic level, you often see that they can produce good responses. And so we need to engage with that. And it strikes me sometimes that we use terms like hallucination or slop. Obviously, we use them in a very derogatory way, right? But we also used to have terminologies like human error that we also used in not in a derogatory way, but in a dismissive way, as to end the discussion. Okay, if it's human error, we don't have to discuss about anymore. It's the fault of the human end of an analysis. And sometimes I think, aren't we when we use all of this, quick fire terminology like slop and hallucinations, sometimes we're using it in the same dismissive way. And my advocacy is to really focus on our human factors mindset, which we have, especially in the last 15 years, we are focusing more on what goes right. We are questioning things more deeply, and we're not satisfied with these superficial analysis like it's the fault of human error. So that's my advocacy. I hope we can do that a bit more, but it only works if we all engage and use these tools more and critically evaluate them like really deeply. So that's my rant done. Okay, so now another point, maybe a controversial point, we'll see. Why are language models a game-changing technology? Name 2 reasons. So we will take, so I give you 5 seconds to think about it, and then I will ask you for your opinions. Let's see if no one volunteers that I can pick someone from the audience.
We have a hand raised by Emily
Yes,
Howard.
please go ahead.
Okay, would you like me to take Emily Howard off mute?
Yes.
All right, Emily, get ready. You're about to talk.
Emily, let us know your thoughts. Why are LLMs game changing?
Didn't realize my hand was raised, but I was about to type something.
We need voice. Give us voice.
I have one reason, which is I'll call lightning fast planning.
Lightning
right?
fast, what?
Planning,
Planning, yeah.
like travel planning, meal planning,
Mm-hmm.
just give it a problem that needs a sequence of responses, and it will give you a lightning fast response.
Okay. That is certainly true. It's very impressive the way it explains itself, or it makes plans. If you use it for programming, that's so very impressive how it sort of goes through its little process. Definitely.
We've got a few other people. We have
Yeah,
something
let's
in the
go.
chat. Shannon McGarry says clear, concise responses to queries.
Okay.
And then Sinan Abdullah, are you ready to rock? Because your hand is up. I'm going to let you talk. You can
Hi,
come off
everyone.
mute, There you are. Hello.
Hello.
Perfect. Great to see you again, Michael. This is a tough one. I'd say one, the incredible information curation. It's really like a Google supercharged, if you will. Does a really great job at providing information relevant to the user. And second, this is not necessarily inherent to the LLM, but can be built into an LLM-based system. The ability for personalization through memory, through other means, I think is really powerful.
Yep,
Mm.
that is definitely one I kind of had on my list of the two mains.
And
So
we have one more.
let's take one more. Yes.
One more from Abigail J. You ready, Abigail? I'm going to let you talk.
Okay. So I think so. I had like three things, and first two people mentioned the first three that popped in my mind. But I think one thing that I see also like in the classrooms when I teach students is that it's not something about technology, but I think it's something about people. Like everyone else is using it, so like they feel like they're behind if they don't use it. So somehow like students try to like use it for something, sometimes like something for brilliant, but sometimes just for really random things. So I think that's also part of this LLM being a game changer because everyone else is using kind of like cell phones, like smartphones, like so many things these days are like not possible to do without those smartphones. So I think that could also be part of the reason. Yeah.
Cool. Well, I will give my 2 cents. So the first one for me, and that really guides like all of the research questions that I look at, for instance, human reliability analysis and LLMs, they all focus on the first one, which is we've never ever had a technology that understands a domain. We've never had a technology that understands the work of a doctor or a pilot or a teacher or a researcher. It understands human factors, concepts, etc. And you could argue what we mean by understanding, but we used to have expert systems there where we had to painstakingly give them if-then rules or other rules, but we never had this ability. I think this is the absolute game changer for me. The second game changer is context. For human factors, I think context is probably the most important concept that we work with because everything is context dependent. And the way, I mean, context is a technical term for language models, and it maybe isn't 100% what we mean by context, but certainly, and I think one of the contributions went into the personalization side of it. I think that the memory of what has come before, imperfect as it might be with language models, is the other one. And I think if you think about a system, for instance, that can analyze a training simulator run, I think context awareness is incredibly important. And I think those two are obviously related because you can't understand the context if you can't understand the domain. So I'm glad that no one disagrees with me. Just in case someone had disagreed with me, as you all know, you can ask questions to an LLM like, which is more demanding, a VOR approach or an RNP approach? Explain that to me using psychological and human factors concept. If you give that to Claude or ChatGPT, I guess some of you know what a VOR is, but Claude definitely knows, and it tells us this answer here. The more demanding approach ultimately depends on the pilot's training and background, blah, blah, blah. But if you go through this, it's a very respectable breakdown of the problem. It shows understanding that is probably better than certainly the average person's understanding. And we always say, well, it just learned it from books. Well, of course it learned it from books because in some ways we all learn from books or experience, right? But I'm not sure. I doubt that this specific question is written in any book. So what it means obviously, now it's not rocket science what I'm talking about, but it can put its different sources together. So it can put together knowledge of aviation and knowledge of human factors and kidney. And so what we'll be looking at in this a bit is how can we make this more predictable and more reliable and better. So now we are jumping a bit more into the technical aspects of it. I just want to I want to bring this up. because sometimes related to this issue of human factors and AI, sometimes it seems like we're still stuck in the 2022 phase, which is I think it's November 22 when ChatGPT comes out, and this already seems like the Stone Age, because it was, for me, when I first saw it, I thought it's Eliza on steroids. It's a chatbot. You can chat with it, but very quickly we had it developed, really evolved. So 2023, we got retrieval augmented generation, where you can upload your own documents and it takes them into the context. And 24, you have the multimodal LLMs, where they can understand images and videos and generate them as well. And then you have the agentic one, which is what we are going to look at a little bit more today. Okay. So now let's sort of take the other side of this. What would it look like if we want to understand flight crew behavior with a language model? And you could substitute that with situation awareness. How could a language model have situation awareness of what happens on the flight deck? I'm going to avoid that framing a little bit, because I think it's much more productive to look at feasible use cases for the LLM, because I mean, we could say, okay, the LLM can be a co-pilot, but I think that is not really helpful. I think it's much more helpful to look at smaller, less safety critical use cases and really get experience, because as you saw in this timeline, we're only 3 years into this whole development. So we're going to keep it a little bit more in training analysis, behavioral analysis, but it sort of overlaps with. So we're going to have a look at some, I think there are 3 key concepts that I think we need to talk about. The agentic architecture and why it matters, the knowledge side, and I mean, obviously the LLM is sort of the spider in the center of the web, and the concept of some technical concepts behind that. But the agents and the knowledge base and the structured knowledge is the key that I want to talk about. I think, no, hang on, I jumped. Okay, the first we have to talk about is MCP. Okay, so if we look at this, go back to this one here, we see at the center of it is the LLM agent, is a language model. And in the ChatGPT era, this was just a conversation agent. But now in the agentic era, the language model can use tools. It can go out and investigate stuff. It can go out and browse the web and find information. It can connect to a weather database. It can connect to my simulator. It can connect to my eye tracker. It can probably start and stop my eye tracker. It can develop its own analysis algorithms for blink detection, and then connect to my eye tracker. It can generate it can generate areas of interest that it might want to know about. And it can look into the training curriculum. It can analyze the scenario that the instructor wants to know. And how does it do that? It doesn't have that all built in. So the agentic sort of, I don't know, revolution or whatever, is that it now has specific tools, so that instead of having everything in its cortex, it can specifically go out and pick and choose exactly what it needs. So it's not going to ask for the weather everywhere in the world. It's going to ask for the weather conditions at the Oslo airport. And then it's going to look into Oslo airport air traffic control map to see which of the airplanes have got pushback clearance. And then it's going to check if the pilot in our simulator has asked for pushback clearance and so forth. So instead of having to process the data of the whole world, it now has a very precise set of tools where it can pick and choose what it needs to know first it has to decide what it needs to know, and then it can pick and choose what it needs to know and use these tools. So that's sort of the agentic turn. Okay, so where are we now? All right. And the way this works, if you want to do it yourself, it's really quite easy. If you use something like ChatGPT or Claude, which I use, it needs to have an MCP server. MCP stands for Model Context Protocol, and it's basically kind of an intermediary so that the language model knows what kind of tools it has. So it has a hammer. A hammer is the, Meta, the weather forecast, and then it has, it can look into the air traffic, and then the MCP server is a sort of a unified little agent or a program that then goes out and connects to the weather database or connects to my flight simulator or to my eye tracker. So in my Claude, I will show you in a second, it has a whole bunch of these little tools, MCP servers. When Claude starts up, it reads all the tools that it has. And then when I ask it a question, instead of just using its vast cortex of information, it knows, aha, I have a question about air traffic. I can go directly to my tool. I don't have to make something up. I have a tool and I can use it, and I can try to answer the question with that. So it's an MCP server. Let's have a look at this in action. Here's a very simple video of it. I wish I had a more sort of polished or comprehensive one, but this will do for now. So here we have Claude open. Claude has an MCP server that I coded or vibe coded. Took about 5 minutes to get that MCP server. So now I have a connection, and now I can ask Claude, what's the state of the aircraft in the simulator? Then Claude has these little, we'll see a bit more of that. It goes and figures out how would I answer that question. So it looks at what tools it can use, and it will go and ask that information, and the MCP tool will connect to the simulator, retrieve that information, and pass it back to Claude, and Claude will then analyze it, put it together, and show me. I'm going to highlight a bit of an issue here. So it gives me a very nice overview of so this is a A320 that's parked at Gardermoen at the gate. And I just want to know what's the state. And it tells me that the engine RPMs are 11,296 RPM, which would not be very healthy. So we'll come back to that. So what I'm saying is it's not perfect. And that is one of the issues we have to look into. Now, what I find really fascinating, so now I ask it, is the aircraft ready for pushback? Now, remember, I have not taught anything to Claude in that regard. So now Claude is working out, what does it mean for an Airbus 320 to be ready for pushback? Then it works out what variables do I have to request for that from the simulator. So it has it seems to have built in a complete list of the simulator variables for Microsoft Flight Simulator. And then it gives me a report on that. Let's just jump forward. So it now gives me a report. It gets the data back from the simulator and says, okay, these things are done, but the parking brake is still engaged. So yes, you need to release that before. So very simplistic. Then I ask it, what is the state of the aircraft lights? Because I want to know if it can put the situation together, depending if you're at the gate or if you're starting your engine, different lights have to be on. If you're taxiing, different light. If you're entering the runway, you have to put down different lights. So I wanted to see if it has that knowledge. And it says, yep, the beacon is on, the nav lights are on, and the logo lights. So that's good for engine start, but we're not ready for taxi. So you need to put on the taxi lights. And then, I'm not sure if that is right. Strobe lights, probably not. So why this is interesting is, and this is not situation awareness, obviously. But this shows a level of understanding. I give it, I ask a question in a very generic way. I just ask, is the aircraft ready for pushback? So there's a lot of contextual understanding that now needs to happen. So the language model first needs to know, well, what aircraft are you talking about? Okay, it's an Airbus 320. You didn't tell me that, but now I know. Now I have to figure out what conditions you're asking me about. And then I have to figure out how to get that information. And then I have to provide a report and an answer. And and some of you in the feedback said, it's really good at planning and doing these things. So yeah, I think this is why it is in some ways a game-changing technology, because if you compare that to any expert system that we had previously, this would have been extremely hard. And as I said, from a technical development point of view, this was a 5-minute programming exercise or vibe coding exercise. So there is a huge imbalance on how difficult, it was not just that it was difficult with previous technologies, it was impossible. It being so easy isn't necessarily we have to be a little bit cautious when things become too easy, because it gets very tempting to just throw everything at it. So there is reason for caution. But I wanted to show you that I think this is the point where I ask it, hang on, you told me previously that the engine RPMs is 11,000 RPM, but as you can see in the video, we are at idle. So it then goes and checks it, and it tells me that it misinterpreted. It basically asked for the wrong variable, or it misinterpreted, or yeah, it wasn't. It now corrects that it didn't look at the right variable. So now it gives me the right answer. And I always find that fascinating that usually when you ask it or when you question it, it will come up with a right answer where you think, well, why didn't it come up with the right answer in the first place? Okay. Right. We have 25 minutes left. That's okay. Let me jump to the next question for you. Why are agentic architectures a game changer? Now, I hope there is at least one brave soul who can take a guess. I give you 10 seconds to think about it, and then either write it in the chat or speak up. All right, any takers? Oh, too late. Okay. Okay, let's move on, and I will tell you my view on it. This is another view of these the way these work together. So what are the two game changers of agentic systems? Well, first of all, as I said, an EMS or an agent, an LLM agent, is a system or program that goes out and asks for specific information. The difference is, as you saw in the video, that the agent or the LLM, when I ask it a question, it requests maybe 5 or 10 data points from the simulator. If you don't have an agent like that, it would have to look at all of the data, because you can put all of the data into the context of the language model and say, we have maybe 4,000 variables. Here are all of them. Just work it out. But that has two problems, which are the two main reasons I give here for why they are game changers. One, of course, you have to request and process 4,000 variables versus specifically looking at the 4 or 5 variables that you actually need. So it's not trivial for an LLM to process 4,000 variables. It's much easier if it actually has a plan and knows this is what I need to know and this is what I get. And this is what I reason about. So the data reduction and also the reduction in processing needed to process a context of 4,000 variables versus 6 variables is huge. But the other hopefully what we can capitalize on in the future is the act of requesting those specific 6 variables about, for instance, the lights or about the pushback conditions. It really gives us a very good insight into what the LLM is thinking about, because we now know it wants these 6 variables and nothing else. So if we look at that as a human or as another agent, then we can say, well, it's looking at these pushback, these variables, but really pushback also requires all of these 3 or 4 other ones. So it seems to have a blind spot in its attention. That could potentially be really valuable for us for explainability and transparency. Compare that to when you give it, 4,000 variables, you have no chance of finding out which of these 4,000 it actually used. Probably it's impossible on a technical level, but I'm not a computer scientist. But for me, as a sort of simplistically thinking human factors person, it is a very, very interesting to observe its way of requesting information, because this is exactly what you and I would do if we are in the cockpit and the other pilot asks us, what is the state of X, Y, and Z? We would ask, tell us where the switch is. So in terms of transparency and explainability, I think that will be a very important way, which is why I think we should, as much as possible, use agentic systems and track that communication that I had here, like closely look at this and maybe visualize that communication instead of just giving it blah. So that is my 2 cents on that. Okay, I'm not going to belabor this too much, but I just want to say that we are developing now the new version of Synopticon, which is called Synopticon API. It is going to be, I talked about what it will be. It's a multimodal behavioral analysis platform. It will basically be a data layer that connects to simulators, to knowledge structures, and to sensors. And it can pre-process them and make it easier for you. Everything that Synopticon API does, you could do yourself. But it's just going to be everything in one place, and it will be easy for the language model to orchestrate that. So it will be easy to say, start the eye tracker now, and the language model will know exactly what format the eye tracking data is coming in. It's going to have some of those. At the moment, you can go to the GitHub. I would not recommend you downloading it because it's really an internal build at the moment. It already has some simulator and sensor integration and pre-processing pipelines, LLM integration. It's not yet connected to the visualization the way that the old version was, but it will now be completely separate. So the visualization will be a separate layer from the data layer. This is how it looks. Okay, so, but we now talked about data from the simulator, but that's not all of it, right? So we need other data sources. I'm just going to show you a couple of examples. So another data source is speech. Synopticon API has a speech analysis module, and this is a demo of this speech analysis module. So here you'll see in a second playing a YouTube video about aviation. At the top here, top left, I have a system prompt of what I wanted to do. And on the top right, I have some analysis questions. So I ask it, analyze the sentiment and identify the most controversial statement and identify any hazards. So this is an example of how a language model, so at the moment I put that in manually, but the idea is that a language model can monitor the conversation of the pilots and orchestrate and pick out, instead of just putting the whole conversation into the context, the language model can now specifically listen for themes or listen for problems or listen for anything it's actually interested in any format that it wants. So for instance, up here, I give it the instruction, do a sentiment analysis, but only give me 5 keywords. And then it tells me, angry, whatever, indifference, reluctance, frustration, disappointment. So this is just a simple example of how and what it does is it takes 20 seconds, it listens to the microphone, it takes 20 to 30 second chunks of speech, merges it together with a previous conversation, pushes it to a language model together with these 1, 2, 3, 4, or however many analysis tasks, and then returns the output from it. So there's a language model that analyzes the conversation of the pilots or of the YouTube video according to any number of instructions that you give it. And that way, a language model that has situational awareness could now specifically get specific pre-analysis of continuous sort of updating analysis of what's going on. So if I want to listen in, have they discussed the engine fire? You could say, what are the problems that the pilots have discussed? What are the checklists that the pilot have performed in the last 10 minutes, or a specific one, have they run the engine fire checklist, for instance? So that's, and this is like just a demo user interface for that, but of course it's sort of part of the data layer to do that. So this is another example how a language model that has situation awareness, or that is your engine for analyzing a training scenario, that it can orchestrate things. Here, if you're interested in developing your own, I use Claude Code, but it probably works with Gemini or Copilot. So here's just a sample prompt that I would use. For instance, develop an MCP server that allows Claude Desktop to communicate with the Pupil Labs eye tracking glasses and so on and so forth. So it's sort of doable, or eventually you can use a tool like Synopticon API. I'm going to jump out of the PowerPoint. I'm just going to show you a quick live demo of some of this functionality. If I can do that, let me just say here. Yes, share desktop. Desktop one, share. Okay, hopefully you can now see my desktop. So let's have a look here at another example of an air traffic control situation. This is Frankfurt. This is a virtual air traffic control network where people sit at home flying airplanes and other people fly or provide air traffic control. Here in my Claude, I have an MCP server to connect to that network. And now I can say, give me the VATSIM traffic info for EDDF, which is Frankfurt. It will go and hopefully figure out what to do. Thinking. So now it gets the airport traffic. It requests from the MCP server airport Frankfurt, and the MCP server has a number of commands. So now it gets this data back and it just renders it to me. So it says traffic summary, blah, blah, blah. Okay, but now we wanted to challenge it a bit more, because we don't just want statistics. Let's see if it can work out current operating status, evening peak period, heavy, simultaneous. What is the next flight to depart from EDDF? So now, I mean, this is not, there is no direct data. The network doesn't tell you, it doesn't have a variable directly that says, the next departure will probably be Lufthansa hotel so-and-so. So let's see if it can work it out and what it asks. So it says, give me all the departures from Frankfurt. And it says, based on the current departure, Lufthansa 31 Juliet is the next to depart, blah, blah, blah. At 727 knots ground speed, this Lufthansa flight is the fastest moving aircraft on the ground and is clearly heading towards the active runway. Other departing aircraft include Condor and so on and so forth. This is the British Airways. So it's sort of correct. I think it's a good guess given, or it's actually a correct analysis, I believe, given that there is no direct variable to use. Okay. Okay, so so unfortunately, I don't have a demo yet where these two are combined together, but we're working on it. Just to show you some more functionality from Synopticon. So Synopticon also has face modeling, so you can stream these data to another AI to do, let's say, emotion analysis. Okay, I will try to get through the rest of it in about 5 minutes. We're coming to the end, but let me jump back to my presentation. Share, Sim, Claude, PowerPoint, share. Because now we have to talk about one more very important topic, and that is data structures. Can you see my presentation mode again? Hopefully you
Yes,
can.
we can. Yep.
Good. So in the last 5 minutes, this is really quite important. Why do we have problems? Why do we have problems like hallucination? Well, it's a difficult question and a difficult answer, but it also has to do with the problem that all of these language, the whole language sort of corpus in the language models is made up of tokens and vectors, and it's not, we need to communicate in a more structured way. And by that, I mean also pragmatically that we need to, if we ask the same question, we want to get the same answer from the model. And we also want to make sure that if we have a specific operational rules like a SOP, we wanted to stick to the Lufthansa way of doing that and not just randomly take something out of its vast corpus of, Delta Airlines and Singapore Airlines. If we want to be able to constrain it to certain ways of thinking. And that is a problem, because if we just use language, that doesn't work. A few months ago, I thought the solution was structured data objects like JSON objects. This is what a JSON object would look like. It's very impressive if you ask a language model to make an analysis of a domain. It will give you these extremely elaborate, really nice looking data structures with the labeled labels, keys and value pairs. The problem is every time you do it, it invents new labels. It's never consistent. So you really need to tie it down to an ontology. So JSON objects, I highly recommend using them as much as possible, because that the language model processes them different from normal language, because it preserves the boundaries of the key value pairs, whereas in normal language, it just completely jumbles up into token. So JSON does have advantages, but it's not the silver bullet. At the moment, people talk about knowledge graphs. I'm not sure if knowledge graphs are the silver bullet, but we are all everyone's looking into them. This is a knowledge graph of an emergency procedure in the nuclear industry. I'm going to talk, just to finish up, a little bit about knowledge graphs. If you want to play around with knowledge graphs, it's really simple. You can use an LLM to generate a knowledge graph, and then you can visualize it. So here I've given it the instruction, describe the interaction between a surgeon and a nurse during open heart surgery as a knowledge graph. Include safety and human factors issue. Use RDF, which I will explain in a second. And the format is a visualization I want to use. Mermaid is an open source graph visualizer. So if you do that, the language model will give you a code that you can copy into Mermaid, and you see the link there, and it will visualize. Well, you'll get this, what I show here. But let's have a look what it comes out with. So RDF is basically a subject, predicate, object triplets. It stands for Research Description Framework. And now with this prompt, let's have a look what it comes up with. So now what I'm trying to do with this is to get it from just constraining it away from a vague, it's hundreds of thousands of pages of nurse, heart surgery, surgeon, medical. I wanted to have a specific way of thinking about a problem. So I get it to generate that one. I could, of course, generate it myself. So now let's see how this includes human factors and operational things. So nurse uses verbal communication, surgeon interprets nonverbal communication, nurse provides nonverbal communication, surgery requires timeout, timeout verifies patient, nurse maintains sterile field, nurse performs instrument count, nurse anticipates surgeon, circulating nurse monitors the sterile field, circular nurse documents the surgery, surgeon experiences workload, nurse experiences workload, surgeon creates time pressure, Time pressure increases workload. Workload degrades situation awareness. Surgeon is susceptible to fatigue. Fatigue impairs verbal communication. Fatigue reduces situation awareness. So if we build these knowledge graphs, we may be able to constrain it to thinking about the problem always in this way. So if we tell it, analyze the training records that we just, or the training video that we just recorded in a surgery simulator, but only use the concepts in the in this knowledge graph, we might be making progress. Of course, there's a lot of problems because they can become very big and they need to be connected. So you need to have domain specific, you need to have concepts, like you need to have a whole knowledge graph about what situation awareness means. Okay, finishing up now. Human factor, situation, and language models, the positives. It's the first ever technical system with domain knowledge and human factors knowledge. It provides, it can understand contexts, and it can have agencies. The remaining challenges for me, of course, we talk about the ones at the bottom quite a lot: explainability, hallucination, and transparency. But I think we need to dig deeper. What I'm interested in is behavioral predictability, sticking to the rules, structuring, linking, and validating knowledge. Maybe the knowledge graphs are the solution. I'm not sure. I don't think they will be the silver bullet either, but hopefully something will come up. Another problem is language is slow, so it's not really a real-time system, and we have problems with processing time series data. Okay, with that, I come to the end of my presentation and my time. I want to just make a call for action. As you can see, we've thought about these quite a lot. We have a lot of tools. What we don't have is students. If you are at a university and have students, please feel free to contact me for a collaboration. Or if you work in a certain domain and want to talk more about structuring data or using these tools, please contact me. We're always open for collaboration. Now we have 5 minutes left for comments, so please let me know if anything I can clarify. Thank you very much.
Of course, you have one question from Catherine Tippy. Catherine asked, can you please share the GitHub links in chat?
Yes.
Great.
I will do that while I listen to the next question. Hopefully someone will come up with a question and I will just find the link. Synopticon API, yeah. Also, we will somehow make these available, the slides available to participants without the videos. I think we can't upload the videos because they are too big, but also watch the LinkedIn of HFES Nordic and ACTG. I will find a way to share them and link them. Yeah, so this is the GitHub link. If you decide, if you're brave enough to download it, make sure you have a coding agent that can help you with it. It's an internal build. It changes all the time, so it's not really ready for consumption. The slides will also have the link to the old version, but I think I would give it another couple of months until we have brushed things up a bit. Or talk to me and I will, if you need a specific tool, I will give you some advice, because it might be easier for you to develop a specific tool to communicate with your EEG headset or eye tracker, rather than using a kind of a full scope data platform like Synopticon. Yeah, okay. I think I covered everything here.
We have one more question that just came in from Sinan. So Sinan asks, I know, good. You have so much content, but it is so cool. Sinan asks, I see the need to add structure to the way LLMs approach problems. However, will this limit their ability to solve edge cases?
Well, I think this is where we just have to go back to the engagement. We just have to try the hell out of all of this. I don't know. I doubt it, because what I have, my experience is even if you constrain it quite a lot, if it comes to a point where it wants to give you answers. So my experience is it will go over any rule you set it. I have not been able to constrain it so it doesn't break my rule if I push it repeatedly. So if I give it a coding task and I say it's not working, it will keep going 4 or 5 times. And the 5th time, it will come up with a solution, but it will break a rule that I've given it before. So I think it will be a matter of handling this issue. It's very interesting. We have to try it out, but we do have to start working with knowledge structures because that is the biggest problem. That is all like sand running through our fingers if we just use. I mean, the great thing is it is an expert on everything already built into the model, but it's a sort of unpredictable expert, and we cannot really. We need to make sure that yes, we have a pilot, but it's a Lufthansa pilot or a Delta pilot or a Emirates pilot. So those are the problems we have to work with.
That makes a lot of sense. Got anybody else? We've got 1 minute.
Do you hit problems with LLM memory and limited context windows, or does the agentic overcome this? So far, yes, it is not filling up the context. The problem is we need a way to process time series data. There are some obvious options, but none of them is really elegant. There are more hacks. That is, if anyone wants to approach a really important research question, it's time series data for LLM consumption. And that, yeah. Cool. It looks like we are at the end of the time. So thank you very much again. Remember, Augmented Cognition Technical Group, join it. If you're in the Nordics, especially, join HFES Nordic. Also, join HFES next year. The HFES Aspire meeting will be in Reno, Nevada. We will have an ACTG social event there, and I hope to see many of you there.
Yes. Thank you. Oh, no, we had one more. Is it possible? One more, Michael?
Sure.
From Abu Bakar, he asks, do you think we can get a better prompt with JSON objects?
Do you think you can get a better prompt with JSON objects? Well, JSON objects, I think the prompting is not, if you give it, the JSON objects come in, if you, for instance, if you ask it about a situation in the cockpit, if you ask it to analyze something, it's better when the thing it should analyze is in JSON than in just plain text. So what I do is I get checklists and procedure, I get them converted into JSON because then at least that part is pre-structured. I also get all of the knowledge. I have knowledge or JSONs for situation awareness, for workload, that has all of the sort of definitions and it's all neatly organized. And then the language model uses that. So I think the prompting is, I don't use it for the prompt itself. I use it for the knowledge where I wanted to stick to certain ideas. And that is easier than giving it a PDF file that just has like stuff, in it. So that was my advice. Yeah.
Wow. Thank you, everybody, for your questions. We are officially over time.
Nice.
All right. 1 minute.
Okay. Have a good evening, and I'll talk to everyone soon, hopefully.
Yeah. Thank you, everyone.
For your attention.
Thanks so much. Have a great day, y'all.